Hello, in this video I'm going to present to you two inequalities that just happen within a triangle. So we've been talking about algebraic inequalities, so now we're going to kind of shift gears a little bit and think about inequalities that exist within geometric figures. We're going to start with triangles. One neat thing about triangles is that, well, they're triangles. They're three sides, and I can find the lengths of each of the sides. I can measure that length, and I can find this length here, measure that length, and I can find this length here, and measure that length. And what we'll find has to happen is that, well, in order to be a triangle, any two sides has to be longer than the third side. Okay, in other words, the sum of any two sides, any of these two numbers, has to be greater than the other third remaining number. And let's just make sure that works in this particular one. So if I want to measure, I'll bring up a calculator. Let's say those two added together. That has to be, that 20.2779 has to be greater than 14.11. Okay, so that works there. And well, let's go ahead and see if that works with the other two sides. So I'm going to bring that calculator back up. And okay, so what of these two sides? Yeah, well, good. Those two have to add up to be more than the third remaining side, 7.747, and they do. And so let's just make sure it works for the final combination. And the final combination would be, oopsie, let's get rid of that. The final combination must be that the first side and the third side have to be bigger than the remaining side, and of course 21.59 is greater than 12.8. So that's what's called the triangle inequality, and here's what it says. Any two sides, the sum of any two sides has to be greater than the third. Here's why. If that weren't the case, then if two sides were equal to the third, we have a line, which I guess technically is a degenerate triangle, but let's assume it's not. So here these two would be equal to the third side, but that's not even a triangle. Let's not even consider that case. If those two sides were less than this third side, well, that would mean that, let's suppose you're standing right here, right at the store, and you want to get over here to school. So you're out getting a cheeseburger at 7-Eleven during lunch, and you need to get back to school. So in order to do that, you would take the shortest path, because of course you wouldn't want to be late, and that length would be the shortest path, right? The distance between 2 points, the shortest distance, is a straight line. But that way, therefore, if you take this indirect path, so if you go over to so if you start at the 7-Eleven, you go over to some other place and then back to school, that would be longer than the shortest distance between 7-Eleven and school. So basically, in order to be a triangle, any two sides has to be greater than the third. So that's what's called the triangle inequality, and we can summarize that here. So for any triangle, okay, any triangle, whether it's isosceles, scalene, right, or otherwise, any two sides sums or adds to be greater than the third, or more than the third, the remaining side. And it has to happen for all combinations. Okay, so basically we have what's called the triangle inequality. This is called the triangle inequality. And we have a triangle here, any old triangle, and that's A, and that's B, and that's C, and those represents the side lengths. Then here's what has to happen. A plus B has to be greater than C, right? So that plus that needs to be greater than this length. Okay. Additionally, the other possibilities also must uphold. Okay, A plus C has to be greater than B. So A plus C has to be greater than the remaining third side. And finally, the last option would be B plus C has to be greater than A. Okay? So that's what's called the triangle inequality. And we can use this. Let's suppose we had 3 sticks, and one was of length 10, and one was of length 5, and one was of length 2. can those make a triangle? And the answer is no, right? And here's why. No. Right, here's our 10, and here's our little 5, and here's our little 2. Okay? No matter how much you swing these inward, these two guys are just too short. Okay, if it did make a triangle, assume it did, then 5 plus 2 has to be greater than 10. Right? And of course that's not correct. 5 plus 2 is 7, which is not greater than 10. So no, those lengths cannot make up a triangle. So that's called the triangle inequality. Any two sides has to be larger than the third side of any triangle. Okay. There's another triangle inequality, and I call it LSLA, which stands for larger side, larger angle. And basically what this says is the larger the side or angle, works in both directions, of a triangle, the larger the angle is across from it. Across that side. For example, and again I call that LSLA. So for any one triangle, if I have this triangle here, okay, and let's make it visually an obtuse looking triangle. If that side, if that angle is called A, so if A is the largest angle, then the side across from A is the largest side. And it works in both directions. If this is the largest side, then that's the largest angle, or vice versa. Okay. So one possible way to use this would be in a problem that looks like this. What if, suppose, shout out to Kobe, what if suppose we had this triangle in 10, 12, 13, and note that those lengths can make up a triangle because 10 plus 12 is bigger than 13, 12 plus 13 is bigger than 10, 13 plus 10 is bigger than 12. So it's legit. It satisfies the triangle inequality. So what's the largest angle? And so let's name the angles. I'll call that A, B, and C. So based on the lengths of the sides, we can order the angles. So here's my largest side, which means that A is my largest angle. So the measure of angle A is the biggest angle, right? My second largest side is 12, so this angle across from that, which is B, is the second largest angle. And of course the smallest angle is the one across from the smallest side. Here's my smallest side. C therefore is the smallest angle. Okay, and that's called larger side, larger angle. So the largest angle is A because it's across from the largest side. Smallest angle is C because it's across from the smallest side. Okay, so we can order sides knowing angles or how they're related to each other, or we can order angles knowing how the sides are related to one another. Okay, so two ideas: larger side, larger angle. Larger the side, larger the angle is across from it in any one triangle, and the triangle inequality. Any two sides for any triangle has to add to be greater than the third side. Thanks a lot. Thanks for listening. God bless America.